Hi, welcome back. So let's have another example regarding the our topic, which is the integration by parts using this our formula. So say we have x tangent or tan of x dx. Okay, so we have something like this. So we have x and then arctangent of x dx. So according to our integration by parts, we need to determine first the value of our u and our dv, right? This part. So and also we said last time that in choosing which is u and du, it is suggested that when we choose our dv, it must be integrable. Okay, so as you can see here, which function of x is integrable? Is it this one or this x? Okay. Do we have any integral regarding the arctangent? Okay. So maybe it is hard to think the integral of arctangent of x, okay, dx. So let's try to let our dv as x dx. Okay, let's try x dx here. Then the remaining function of x is we let this as our u. Have the arctan -1 x. Okay, then our next step is to find the derivative of the u and find the integrand of the dv. Okay, we take the derivative of u, so we will be having our du, and we will take the integral of dv to have the value of v. So if we take this, the integral of this x dx is x squared all over 2, right? Okay, while this arctangent of x, so what is the derivative of this one? So last time, just quick review. So last time we have the integral that leading to an inverse trigonometric function, right? So I have our derivative of u all over the constant a that is being squared plus some function of u that is also being squared, and the integral of this is the inverse trigonometric of 1 over a tangent or arctangent u all over a, right? Okay, and then as you can see here in our going back to our solution, we have the tangent of x, so we have the arctan, okay, this one, and we say that if we take the derivative of this, then our answer is in terms of this, right? So as we analyze this, if we take the derivative of this, so we have tangent -1 of x, so this is our variable x. Then since it is only arctan of x, then maybe then the constant that we have here is just 1, right? So that we have 1 over 1, or we cannot sometimes we can neglect this, or we can let this as 1, and any number multiplied by is the number. So usually we don't write this 1 over 1, and also we don't usually write this x over 1 here. So this tangent -1 of x is also equal to this 1. Therefore, if we take the derivative of this, then our answer is the x all over, what is our constant here? We have a, right? We have the constant a is 1, and then plus our function of u here that is being squared is this one, x. We have x squared. Okay, so going back to our solution, the derivative of this tangent -1 x, this is tangent -1 x, is also equal to dx all over 1 squared is just 1 plus x squared, right? Once again, if we take the derivative of this, our answer will be this one. Okay, so this is just a quick review in our lesson last time. Okay? So right after that, we determine the value of u and dv and take its derivative and take its integral, then we can now apply the change of variable in our main solution. So we say that we have x tangent negative 1 x dx is equal to uv. What is our u? We have tangent negative 1 x, and our v is x squared all over 2. And then we have minus the integral of v, which is x squared all over 2, and then our du is dx all over 1 plus x squared, right? Okay. Okay. So where are we? So after doing the integration by parts, we can now we will now try to solve this integral. Okay. So let us first simplify our equation. So say we have the let's move the constant 1/2 outside. So we have x squared dx all over 1 plus x squared, right? But as you can see here, which formula can be used to solve this integrand? Okay, so can we use the power formula? We have, if we use the power formula, we need to take the derivative of this, which is 2x, but we have x squared in our numerator. What if we use this formula, which leads to the inverse trigonometric function? We have some constant that is being squared and some function of u that is also being squared. So we have here, right, can also be written as like that, and we have x that is also being squared. Okay, so maybe we can use this one, but we need to take the derivative of u, which is the u. But here, the derivative of u, of our u here, is 2x, not x squared, right? So let's try to simplify further, or let's try to analyze further. Okay, so what if let's try to add 1 then minus 1 here. Okay, if we add 1, then if we also minus 1, then we're adding nothing here. So it is also, we can also use that, we can also say that x squared is just equal to x squared plus 1 minus 1, right? Because plus 1 minus 1 is, we can cancel that out because that is equal to 0. So meaning x squared is equal to x squared. So they are both the same but in different form. Okay, so why do we need to do that? Okay, so let us now analyze it further. Because if we take this one as x squared plus 1 minus 1 dx all over 1 plus x squared, then doing that, we can now separate this term and the other term. So let's see, we have x squared plus 1 all over x squared plus 1, or 1 plus x squared. We have 1, right? Okay, let me show you. X squared plus 1 all over 1 plus x squared dx, this dx. Then we have 1 integral of dx all over 1 plus x squared, right? Okay, so we can use this. And as we can see here, we can now cancel this out because x squared plus 1 all over 1 plus x squared, or x squared plus 1 is just 1. Okay, so we have minus 1/2 times the integral of 1 dx, or dx, minus the integral of dx all over 1 plus x squared. And as you can see here, the derivative of x is just dx. So we can now use this formula to solve this integrand. And this is a very simple integration, so we can directly use our basic formula here. Okay, so let's now try to take the integral of these two So we have the integral of dx is simply x minus the integral of this one. So we have what is 1 over a arctan u over a. So we have 1 over a, our a is 1 arctan u over a. So we have x over a, or just at tangent negative 1x. Okay, now simplify this. Let's not write this anymore. Okay, then plus c, but we need to add this term arctan x. We have to add this. We have arctan negative x squared all over 2. Yan. Okay. Or simply, how can we simplify this? We have, say, let's move the 1/2. Then what we have remained here is arctan negative 1. We have x squared of arctan negative 1x minus this one, x, then plus tangent negative 1x, right? X squared tangent minus x plus tangent negative 1x, then plus c. So this is now our final answer. Okay, so let's review. We have the x arctangent of x dx. So we say we need to determine the u and the dv. So we have two different functions here in terms of x. So we have to determine which is u and dv. So we say that it is suggested that our dv must be integrable. Okay, so which one is integrable here, the x or the tangent negative 1x or the arctangent of x? So we choose x dx because we can easily integrate this x dx. And after integration, we have x squared all over 2. And then we say that our we let u is equal to arctangent of x. And then from our formula, we can say that the derivative of this is dx all over 1 plus x squared. And then we proceed to the formula leading to the integration by parts, which is this is equal to u, which is this part, and then v, which is this part. Okay, then minus the integral of v du. Our v is this part and our du is this part. Okay, right after that, since we need more to integrate this, need to think of another solution where we can integrate this second part here. Okay, so as we analyze, we already see that we have 1 plus x squared, which is in form like this one, which can be lead to a inverse trigonometric function. But our numerator is in terms of x squared, and we say that we need the derivative of this, which is the x only, but we have x squared. So we transform our numerator to something that might simplify our integrand. So by adding plus 1 and by adding negative 1, so we have plus 1, negative 1, we can say that it is also equal to x squared. So we use that, and then we separate two terms, x squared plus 1 all over x squared plus 1 dx, and then minus the 1 dx all over 1 plus x squared. Then from here, we can now easily see that this is integrable and this integrand is also integrable. So here we can easily use our basic formula, which is equal to x. And then from here, we can now use our inverse trigonometric function, which is equal to arctangent of x and then plus c. Then we simplify. We can simplify by factoring out our 1/2 and then the remaining terms inside. So we factor out the 1/2 here, so we've left with x squared and then arctangent of x, and then minus this 1/2 here, we move here outside, and then we have minus x, and then minus times minus here, or negative times negative here, we have positive tangent arctangent of x, and then plus c. Okay?